Okay, we've gotten to percentiles now. In the previous video, we were talking about categorical data, but here we have a quantitative data set. So the numbers in purple are, they represent test scores on a statistics exam, and these were taken by 22 students. So each one represents a unique student's exam score. They've been arranged from least to greatest. And the black number slightly above it and to the right is actually the rank of that data value. So the rank of the 40% is 1, all the way up to the 22nd, which is the 97, the high score. So the range from least to greatest. And what we mean by a percentile, the kth percentile, is the location in the data set. So it could be a data value, it might not be, for which no more than k% of the distribution lies below this location. And something really important here, this k is the percentile rank we want. So when we were talking about percentile rank in the previous video, this is why we need it. So it helps us figure out what percentiles are. So to understand this better, especially if we have a data set that has a not an easily convertible sample size, let's try to figure out how to find a percentile. So find the 50th percentile. And what we mean by that is we want to find the location in our data set for which no more than 50% of our distribution lies below this location. How do we do this? First, identify the percentile rank. So our percentile rank, remember, is just the number, the 50 that we put in front of the percentile. And once we have that, we can use the relationship between rank and percentile rank to figure out what the rank must be. So if we write that equation we had before, and we use this version of that equation, because we have percentile rank, we want to find rank. Specifically, our n is 22, divide that by 100, and we multiply by 50. Here then, we'll get 22 over 2, which is 11. So the 50th percentile is the 11th ranked data value. So we go through our data set, right? And we already have the ranks here because we took the time to write them out. But the 11th data value is 80. Because 11 was a whole number, we were able to do this. If it wasn't, we would have to do something else. And I'll show you an example in a second. But so then what does this mean? What this means is, in context, we're saying that 50% of this sample of students did no better than 80% on this exam. So 80% is the halfway mark. Half of them did no better than this, and half of them did better. Okay, so what happens when we don't have a whole number? So let's do a slightly different percentile then, one that won't be easily cancelable. So find the 21st percentile. So, in other words, we want to find the location in the data set where no more than 21% of the students did better than this score, right? So same process. Percentile rank is 21. We want to find the rank. We multiply that by 22 over 100. And nothing cancels out very nicely here, right? Except for maybe dividing both of these by 2. So then if we do this calculation then what we would get is 4.62. So the rank isn't a whole number. What happens then? What do we do now? So we find the two data values around that rank. So the 4.62, that lies between 4 and 5, which means our percentile, so the 21st percentile, will be the arithmetic mean of the 4th and 5th ranked data values. Only when we have a non-integer rank do we have to do this. Okay, so if we go back to our data set, what would that be? We'd be looking at these two. And so we take the arithmetic mean of 69 and 70. So 69 plus 70 divided by 2, and that should be 69.5. So nobody in the data set itself got 69.5%. But what we're saying is that 21% of this sample, or population, whichever one we're looking at, got no better than 69.5% on this exam. And that's true. Okay? And percentiles are really helpful because these give us a natural way to partition our data set. So if we think of this as the distribution, maybe this is the trace of the histogram. Whatever our k is, right? So k being 20 or 45 or 100. So what we're saying is the kth percentile splits our distribution into the lower k% and the upper k% of our distribution. This is a super helpful concept which we'll use time and time again, and we redefine it when we go on to probability. One last thing to note, we have some special percentiles that we like to use, which we call the quartiles. So the quartiles are the 25th percentile. So Q1, the first quartile. Splits the lower 25% and the upper 75%. Then we have Q2, or the median, which is the 50th percentile, splitting our top and lower 50%, right in the middle. The median, again, is also a measure of center. And lastly, Q3 is the 75th percentile. We also call that the third quartile, using the word second quartile, and that we usually don't use that. We just call it the median. But these are interchangeable, these are interchangeable, and these are interchangeable. These are special because they split our data essentially into 4 equal pieces. So if your distribution looks like this, maybe that's the trace of the histogram, then we're saying is, okay, half of the distribution, so wherever that line is, that's your median, split the lower half in half again, and now you've got Q1, and split the upper half in half, and you've got Q3. And with that, and two more additional special values, which is the minimum data value and the maximum data value, these 5 numbers make up what we call the 5-number summary. And they're a very helpful way of summarizing relative standing in our distribution.